Hello and welcome to this ARC forum session on the role of 5G in private wireless in digitally transformed architectures. My name is Chantel Pulsinetti. I'm a vice president here at ARC. And along with my colleague David Humphrey, we're really looking forward to bringing you what we see as an exciting session on this exciting topic. Essentially, what we're looking at is we're going to bring you 3 customer use cases, 3 supplier perspectives, a technical update, and of course, the analyst perspective as to what's happening and what we think is going to happen with 5G and private wireless. Please note that we'll be introducing the speakers just by name, title, and company affiliation. You can find their full bios on the vFairs platform. Also, please remember to use the Q&A feature at the bottom of your screen anytime during the session to post questions for the panelists. Once we walk through the formal presentations, we'll have time for a live Q&A, and we certainly welcome your input at that point. So Dave, if you want to launch my perspective on the 5G and private wireless.
This presentation is designed to kick off the session from the perspective of why we believe that 5G and private wireless really are going to be key to the acceleration of digital transformation strategies in industry, and also to share some results from some of ARC's recent research into just how these technologies are going to impact industry. Now, in the interest of time, I'm going to keep it short, but I wanted to point out that what I'm presenting here are actually the results of a strategy report that is available under the Resources tab to all you folks who've registered for the forum. It's a January 2021 report entitled 5G and Private Wireless are Poised to Accelerate Digital Transformation. And this report has sort of a deeper dive on some of the concepts I'm going to share today. One of the most important things to consider when evaluating new technologies is how is it going to help my business or improve my business? Will it help me reduce costs, improve process efficiencies, increase revenues? Will it help me achieve competitive excellence and differentiation? In today's world, will it help me to respond to the new normal business conditions, particularly as it relates to the COVID-19 pandemic? Will it help bring operation security from both external threats as well as internal actors? And ultimately, does it provide a path to product and service innovation to achieve step change in my business operations? So what paths are customers pursuing to digitally transform their operations? Well, depending upon your philosophy, one might be industrial IoT or Internet of Things, which is typically characterized by the effort to reduce downtime and maximize asset availability. In the I 4.0 realm, the emphasis is more about flexibility, reconfigurability, and that batch size of 1. We're moving essentially from automation to truly autonomous operations, and all of this requires the ability to connect product, processes, and services, including those assets and locations that weren't previously served by conventional network infrastructure. And remote capabilities for access, monitoring, enabling remote experts, and training capabilities are paramount to that. And then we also find in the new normal realm an emphasis on personnel tracking and safety. So what are some of the drivers behind market and industry interest in 5G and private wireless technologies? Well, we know that the industrial IoT in general inherently involves escalating connectivity requirements to get data from the field to cloud-based applications for consumption for analytics and similar applications. We know we need more remote capabilities, and we know that customers are trying to integrate assets and locations not previously served by network infrastructure. We talked about the shift towards the centralized, automated, and autonomous operations, and we know that many countries, particularly in Asia, are pursuing national strategies to give themselves a lift through use of 5G. But the technology itself really represents a holy grail for numerous customers as to freeing their operations from the limitations of wired or wireline infrastructure. The inherent technological advantages of low latency, high bandwidth, and massive device density present numerous opportunities that Sander will get into later on in the session. We also know and see from the use cases that 5G and private wireless are seen as the means of enabling disruptive new applications, particularly at the industrial IoT edge, in areas such as artificial intelligence, machine learning, augmented reality and virtual reality, mobility, and autonomy. And as a cellular technology, most customers are used to using cellular outdoors, but many of the tests that we see are now using private wireless and 5G indoors. So as an analyst firm, we like to look not only at the drivers, but also at the inhibitors. So this list basically outlines some of the key ones that we see as potentially impeding the potential for growth in 5G and private wireless adoption. Certainly there's macroeconomic forces. There's also the reality of the life cycles of automated equipment. You know, machines easily run 20, 30 years, and the components inside them, you know, may be very dated and not up to the task for today's connectivity requirements. So then in turn, you're subject to maintenance schedules or new installations. Industrial customers are becoming aware of the significant ecosystem build-out investment that's required, whether for towers, base station radios, or backhaul. And also there's the timeline associated with component availability, particularly chipsets that support 5G and wireless, private wireless. There's also issues around deployment complexity and customer familiarity with using cellular in such a crucial role. And there's also, with the 5G and private wireless installations that we see, there's more of an emphasis on new applications, whereas industrial automation in general tends to be more focused on retrofit at this point. We also anticipate an initial price premium for 5G industrial devices. And of course, there's the need for regional certifications for the cellular spectrum that some customers might not be used to or aware of. There's also issues related to the knowledge base for both the industrial automation supplier and the customer. As I mentioned, as far as the life cycle of equipment, there's certainly a desire for some backwards compatibility, which may or may not be evident. And there's also a lot of different alternatives available relative to the use of 5G technology or other alternatives for private. And certainly there's the issue that cellular spectrum costs money and Wi-Fi and other wireless alternatives don't. There's a significant education requirement for both the market in general as well as companies in specific. And then we need to get over the hype cycle and see what the reality of the value proposition really is. The issue of use of public versus private spectrum is one of the first issues that customers encounter when evaluating 5G and private wireless. Essentially, do you want to operate on the public telecom network of a telecom service provider, or do you want to actually control your own spectrum, which in turn involves buying, licensing, and operating from a network management perspective? So when we look at the issue of public versus private wireless, we try to focus customers on considering private for mission critical operations where they don't want to give up control, for protecting IP or intellectual property for the same reason. Also, if they have large installations with complex needs, we steer them towards private. That issue around the remote locations that don't have any existing infrastructure, and of course, a paramount concern for industrial customers, whether safety is a concern. These next two slides are designed to basically reinforce the points I've been trying to make as it relates to what type of use cases are customers pursuing and what type of innovative edge technologies are employed in these 5G and private wireless trials. So you can see under the use cases, here's that holy grail of replacing wireline infrastructure to enable mobility, automated guided vehicles, autonomous guided vehicles, autonomous logistics, all types of things, improved operational efficiencies. You can see all the different examples here, and again, they're in that report that I mentioned as well. And we also see the innovative edge technologies that are being deployed as part of these installations. Lots of analytics, lots of artificial intelligence and machine learning, and it might not be as obvious here, but also lots of video processing. So, for example, the Lufthansa with their engine inspection is primarily focused on video processing. So these, again, are just to reinforce that concept that there are definitive use cases behind these trials, and they're also pursuing innovative technological adoption. So one of some of the things that you should be looking at if you're thinking about trialing or adopting 5G or private wireless. Well, as we've tried to hammer in our comments here, focus on the use case, business requirement, sought after business value proposition. Keep in mind the timeline requirements regarding product availability, as I mentioned, with chipsets and end devices, and the time it can take to implement these installations, which can be like 4 to 6 months. Sandra will talk a little bit more about the different capabilities inherent in the 3GPP 5G releases, but when you get up to 16, 17, 18, that's where we find the real low latency that meets the needs of industry in our mind. Look at those infrastructure build-out requirements and whether or not you're up for it. Recognize that there is a definitive need for an ecosystem approach to implementation. And as it relates to the ecosystem, a lot of customers initially are looking to the telecom providers whose primary business is really in network management. But then they run into whether or not the telecom providers really have the knowledge required to meet the operational requirements. We also believe that there will be multi-access mixed environments where you might be using Wi-Fi 6, for example, for a single installation, and 5G for more of an ecosystem or plant-wide or campus-wide installation. We also highly recommend you look into dynamic spectrum sharing, or DSS, which is part of the 3GPP standard. This allows you essentially, in our mind, to future-proof installations, which we see as a core requirement for industry. When you're evaluating suppliers, make sure you look at the role of cellular in the supplier's portfolio. Many industrial network infrastructure suppliers offer wireline and a variety of wireless options. So make sure that if you're looking at them to provide cellular for your installations, that it is an important part of their portfolio. And when you get into cellular, it's true for all types of network infrastructure in general now. But when you get into cellular, the cloud-based network management environments are really used as competitive differentiators, and for customer stickiness. So be aware of their importance. So I'll conclude with a quick ad just to let you know that this material on 5G and private wireless is part of ARC's ongoing coverage of the industrial IoT edge. Essentially, we cover the whole IoT stack from the top with the cloud application platforms, the edge software platforms, and all the network infrastructure, hardware, and software. So please reach out if we can help you with industrial IoT edge coverage. Thank you very much.
Okay, so as I indicated in the video, the material that slide deck was drawn from is available on the resource tab on the vFOIA's platform with the name, The Role of 5G and Private Wireless in Digitally Transformed Architectures. So the audience is certainly encouraged to look at that for more details on that. So our next speaker is from Covestro, Pietro Valsecchi, who is the operational excellence expert in process control technology out of Dusseldorf. Pietro, if you could please turn on your camera and share your presentation screen. Thank you very much.
Certainly. Just a second. I need to also get my camera started.
I can see your screen. Looks good.
All right. Can you see my camera now? Should be coming. Yes.
There he is.
Good morning, everyone. It's a gorgeous sunny afternoon here in Düsseldorf, Germany, and I'm very excited about this panel discussion. My name is Pietro Valsecchi, and I am a part of the global process control technology team at Covestro. As an expert in operational excellence, 5G is one of the topics I cover in my daily job. Covestro embraces Industry 4.0, and we are gathering experience in 5G. If the next slides will sound somehow skeptical, it is only because we are investigating this technology seriously, and you move forward only by asking probing questions and, yes, sometimes uncomfortable questions. So please hear me out and don't let the excitement go down on, for the 5G. If I'm not a chemist and I'm not a chemical engineer, although I work for a large chemical company. A long time ago, when I would have thought of production of chemicals, I would have seen this picture. It's a scientist making a new product, a chemical product in a laboratory. Unfortunately, I mean, today in my daily job, when I think of chemical production, this is what I'm looking at. This is a typical production facility. Excuse me. If I look at the picture, then these are the boundary condition I'm looking at if I want to introduce wireless technology. So let me just out of this picture, let me point out a few challenges that are really relevant, because reframing the perspective helps me understanding the framework of introducing new technology. First of all, we are looking at a very large, although it looks compact, these are 7 floors. So it's a very large space, and it's condensed with people and process equipment. And also there is a lot of metal and a lot of rotating equipment and a lot of vessels containing fluids. These are all big obstacles for any type of electromagnetic signal. Also, did I mention that the majority of the chemicals we are using are highly reactive, which means that they are prone to explode in uncontrolled fashion? So this means that everything we introduce there has to be explosion proof, which also limits the type of technology or hardware we bring in. But beside the physical challenges that we are looking at from this picture, let me point out the challenges on the business side. First of all, plants like this grow by addition and patches. This makes it difficult for any smooth and homogeneous integration of new technologies, because there is always one system that haven't thought of and that no one actually reported when they installed it 5 years ago, for example. And finally, this business is cost-driven. Every addition I bring in has to compete with maintenance and has to have a pretty solid business case. And when I say solid business case, I mean it has to bring short-term benefits in addition to clearly long-term benefit, like in the case of 5G. So as I explained before, as cool as 5G technology is, and Chantal just before showed a lot of very interesting application that could really, really benefit the way we produce. However, I have to look at the short term, and today the 3 main use cases in my industry that have concrete and measurable return of investment are the 3 I'm showing here. And the first one is what we call the mobile working. So it's the collection of manual field operation that can be digitized by providing the operator with and technicians with a mobile device. And this is about reducing errors and increasing efficiency. This is really a money maker, because if you have to write things on paper and go back and transcribe it into a system, it's prone to error very often. Very large amount are saved during for the second use case here, the turnaround management. Now, turnaround is we operate 24/7. So those production plants are always running, so we cannot really apply a lot of maintenance or upgrades. So over the years, over the months, we collect all the maintenance activity, a list of upgrades and so on. And every 2, 3, 5 years, we plan a major turnaround where we shut down the plant for a certain amount of time, and we go through the list of all the accumulated upgrades and maintenance. Obviously, every hour we spend not producing is a lot of money we lose. And the ability of increasing the efficiency during this turnaround is key. It really, at one point, it boils down to the difference it makes for an operator to click a button directly after it's done with an operation, as opposed to having to walk down to the office or to the next place where it has a terminal and click it there. Those minutes multiplied by the hundreds of thousands of operations of tasks that are done during a turnaround can sum up to really, really consistent savings. The third case is the IoT for asset monitoring. As I said, we produce 24/7, and we have to have a precise view on the health of every equipment. If I can understand and predict when a heat exchanger, for example, will fail, I can plan for an outage, or I can even change the way I'm operating it in order to fit the next turnaround window. Again, these three items are where today in the chemical or processing industry are the ones that bring short-term and direct benefit. Of course, everyone is enticed by the possibilities that 5G bring in. Like the list that Chantal brought is short, but it's already has a lot of very interesting stuff that I would love to introduce for our production facilities. And again, to implement all this, I need investments. And to the investment, I need a strategy, and therefore I need a clear path on how to match short-term benefits with the possibility of long-term benefits. So let me look at a little bit of the challenges that we have seen so far in our path to 5G. First of all, 5G doesn't come down from the sky. It is still an infrastructure required, particularly for production facility like ours. It still requires wiring cost and a number of hotspots. So it's considerably less than installing a VLAN, but you still have to invest in that part as well. So far, the second point, the challenges that we are seeing is that all the benefit, all the application from 5G tend to focus on how a lot of additional use cases that we could possibly run, including autonomous logistics, for example, or massive amount of IoT device, edge computing. But I haven't seen a use case where 5G shows me to reduce cost on coverage, for example, on the infrastructure cost. So the third point is something also Chantal previously mentioned. There is the hardware for 5G is hardly available for industrial installation, and in particular for our specific case of explosion-proof devices. It's very difficult to find this type of devices on the market, and in addition to that, because the protocol is still being created, if I buy this equipment today, might not be capturing all the new releases of 5G features that will come up over the next few months. In fact, as I point out here, the protocol is still a work in progress. Features like slicing, for example, which will be extremely interesting for us, are slated to become available only at the end of 2022, if I remember correctly, in one of the next releases. So can I invest today in a piece of software, of hardware that I know I will have to replace later in less than a year? And for the moment, as the protocol available today for 5G, for our case, and I'm really specifically saying for the production plants, right now there are no distinguishing, sorry for the typo here, distinguishing features that provide me with additional compelling use cases I can use today. And therefore, this doesn't allow me to bring a business case, and therefore autonomous logistics for production is for us will help a lot, will bring a lot of saving and increasing efficiency. But right now there is, the protocol doesn't offer me enough, or the hardware doesn't offer me enough to bring the same thing for movable IoT. So my challenge for you, this is my last slide here, and I would like to leave you with a challenge, or my question for you. Of course, I'm showing you what I see from the narrow view of one specific industry, the chemical, the process industry. My view is limited and probably obstructed by the limitation of the business case. But what are the use cases that I'm not seeing? I show you three that are today use cases. Chantal mentioned a lot of very interesting application. What are the use cases that I am not seeing here? Second point, or second question I like, or challenge that I like to throw here is, how do I make a 5G installation competitive in the sense of business competitive with a VLAN or an existing LTE? And finally, should we wait until release 20 is fully implemented into hardware, or can we start with a minimum viable product today? What is a minimum viable product today before we reach release 20, or the release where we have all the full features, including slicing? With this, I rest my case and I give the mic back to Chantal. Thank you very much.
Thank you, Pietro. Now, we could start the panel discussion right here with that slide, in my opinion, because you really shared some very provocative thoughts with us, which I greatly appreciate, and we will follow up with on the Q&A. I do want to remind the audience, please feel free to add questions to the Q&A at the bottom of your screen at any point during the session, and we'll bring them up. We'll do our best to bring them up during the course of the live Q&A. So our next speaker is Nancy Post. Nancy is the director of the Intelligent Solutions Group at John Deere here in the USA. I see you have your camera on. So Nancy, if you want to share your screen with us, we're very much looking forward to hearing from you.
Okay, thank you, Chantal. There you go. Can you see my screen?
We might have to give it a second.
Okay.
We're still on the nav slide on my side.
Okay.
There we go. You are live.
Okay. Thanks, Chantal. I'm Nancy Post, and I'm the Director of Embedded Software and Solutions at the Intelligent Solutions Group for John Deere. And I'm going to talk to you a little bit today about how the role of 5G connectivity affects agriculture. We're going to start with connectivity in general and how much of an advantage that is for our customers currently. And then we'll talk about how we can bring about greater advantages if and when we move to 5G, both in the field and within our factory. So our customers are continually trying to optimize crop output. They're looking at the situation in front of them every year. They really have only, in many times, 40 times to make decisions that maximize that output and maximize profitability on their business. Their farming operation is their business. They have many, many decisions to make day in and day out, week after week, season after season, and year after year. And often those decisions the output of those decisions isn't known until much later in the season, or even at the end of the season when they're harvesting their crops. They're making many of these decisions in the face of intense variability. There's always labor shortages, and so our customers are looking at how do they optimize and figure out where to place labor and how to work with the labor shortages that they have. And then there's the planting window. Many people would be surprised to know that there's only about a 10-day optimal planting window for our customers in the Midwest. And that planting window, if you go outside of it, even by 1 day, you can have a 1% reduction in crop output at the end of the year. And then of course there's the weather. The weather varies a lot. Think about the rain, the sun, and the wind, and all the things that not only affect that planting window, but also affect the growth of a plant. You'll see as we walk through this presentation how much attention we give to every single plant. And the plant needs water and rain, and it needs to be planted optimally. And even soil conditions are a great impact on how a crop grows, and that varies a lot from section to section, even on the same farm. So to help our customers address all of this complexity, we are designing and developing smarter, automated machines that are fueled by data. In a production system, we have many different steps: preparing the land, planting the seeds, spraying the plants, and harvesting the crop are all key to producing the most with fewer inputs, but optimizing that output and creating greater output and profitability for our customers. Each pass through the field, we're collecting data. And if we hone in on that planting section, we have a 9R that we're showing there. That's that big tractor in front of a planter. That planter is a 60-foot planter that has 24 rows. And as part of that, there are 300 onboard sensors and up to 140 controllers. So you can imagine the amount of data that's flowing both in that system, but it's also flowing off of that system into our data platform and being added to the passes before it and then the passes after it, and even from data from the year before that helps us to gather insights and help the customer to optimize their operation and produce more and better crops. Our data platform is processing up to 15 million measurements every second for our customers. So you can imagine the power that comes from all of that data that's flowing to the cloud. But of course, connectivity is critical to the success in feeding those insights. Our customers have a very great responsibility to feed a growing population. Currently, we're at about 7.7 billion people worldwide, and it's estimated that by 2050, we'll be at 10 billion. So with that challenge in front of us, we want to make sure that we're giving our customers the right technology in order to increase productivity, and connectivity definitely enables that. With all of the technology that we're talking about, we help our customers to be more efficient, more profitable, and equally as important, to be more sustainable and help to preserve our earth. You can see a picture on the right of a mobile application. That's a view into our operations center, where that data is collected and our customers are able to look at that information and draw insights and even make quick on-the-go decisions. They may help optimize the settings on a vehicle that's in the field. They can compare two different vehicles and send the settings from one vehicle to another so that it optimizes the crop production. There is a tremendous amount of information that we're able to provide our customers because of connectivity. One other example that really speaks to the sustainability of what we're doing is that we have maps. And with those maps, we're able to determine if there's an area of the field that isn't going to be productive. A waterway would be a good example of that. And with a waterway, you wouldn't want to plant a seed because, of course, it won't grow. So you can skip putting the seeds. into the ground. You can skip spraying. The machine automatically skips this once it's mapped. And you can skip harvesting, which saves fuel. So all of those things help our customers to contribute to the sustainability of the earth. Rural connectivity, as you can imagine, or you've heard me say, is of critical importance to our customers. And so we need to make sure that we're advocating at John Deere for rural connectivity overall, and that we're staying in tune to what's going on in 5G, so that as that opportunity becomes more real for our farming customers, we're advocating for that. There's up to 230 million acres across over 100 countries worldwide that are being farmed by John Deere equipment. And on an average farm, there's 350 million plants. And as I mentioned earlier, we're managing this with our customers at the plant level. So we're actually trying to optimize every seed that goes into the ground. If you can imagine, we are actually able to automate systems so that we're monitoring the placement of each seed, the distance between them, the depth, in order to optimize the potential of a plant. So these data-driven insights best address each plant, which then adds up over the course of the year and the season to produce more output for our customers. Broadband and connectivity access is still a concerning issue. According to the FCC, there are 19 million, and that's up to 6% of the population that is not served today by connectivity. And many of those are our farmers and ranchers. According to some of our independent sources, that number could be up to twice that much, or 42 million people that are not served with broadband today. Of course, we cannot provide this amazing technology that helps us to feed the world without that connectivity. So it's a great concern for us, and we want to advocate for connectivity across the world. Our farms need to be able to take full advantage of our advanced technology, and we'd like to help with that. So now we're going to shift gears a little bit into the 5G advantage. So you've seen what 4G already does for us today in the field and to help our customers. We feel that 5G will actually help us to optimize what we're doing today. It's in the field. The examples I've shown you today are definitely in the field, but we have some exciting news in our factories as well. So one of the technologies that we have in the field today is called machine sync. And what this is, we leverage a Wi-Fi or radio systems. We have it in both manners today. And we leverage our AutoTrack, which is automated steering, to keep two vehicles synchronized in the field. In this case, we're showing a tractor pulling a grain cart and a combine. And we're synchronizing position, speed, and direction of travel. And we're sending the combine grain cart status so that we can create a seamless on-the-go unload. What this does for our customers is it makes sure that they're optimizing that output at the end of the season. They're not losing grain due to these vehicles not being synchronized. It also adds an ease of use that is very important to our customers during these stressful times of the year. Today, with Wi-Fi, there is a significant range limitation on the system. With 5G, that range would no longer be a concern. If we had, especially if we had an edge computing system with a 5G network, you pair that with faster speeds, better bandwidth, and the great reliability that we feel we would get with 5G, and it would be a great advantage for this example, but for many machine control type examples in the field for our customers. Another example is virtual fleet management. We have virtual fleet management today. We're constantly monitoring every vehicle that's in the field, and we're looking at status of the vehicles, where they're located, what we could do to optimize the system, especially at really busy times of the year, like planting and harvest. And so, but today we're looking, that data flows up into the cloud across the network up into the cloud and then back down either to the vehicle, or it could be to the operations center that I talked to you about earlier. If we had 5G, we could allow a local, much faster and more reliable network that would allow our customers to make almost instantaneous decisions about what was happening in his farming operation. He could be in the field, or she could be remotely from a desktop or somewhere like that, making the most important logistics decisions about where to place trucks for unloading, where a vehicle needs gas, how would they want to have, where do they want vehicles and equipment in the field to optimize their overall farming system. So we think that 5G would be a really nice advantage to our customers in this case. Now we're going to shift gears to building equipment using 5G. So now we've moved from our vast fields into the walls of our factories. There was recently an FCC auction, and John Deere obtained 5G priority access licenses in 5 counties that correlate to some of our biggest factories. 5G will allow us to harvest information that's critical to the production of our machines and revolutionize production going forward. A few of the advantages of 5G in a manufacturing environment are smart device connectivity. So when we have smart devices that are communicating directly with the network, it would allow us to reduce our in-network drops and our Wi-Fi and associated infrastructure, which would then allow us to have a more capable infrastructure that improves our overall factory performance. But also very important is that it would improve our flexibility. So if we needed to change our line slightly internal to the factory, we could do that more easily than we could with physical drops. The other thing that we feel is an important step is, as Pietro mentioned, we would have a considerable investment initially with 5G, but we think that that infrastructure cost would last us more on the order of 10 years, whereas today when we make significant infrastructure costs, we can only count on that lasting for around 5 years in our factories. And then it would also help us in quality of service. So with the low latency on 5G, as well as the high bandwidth and higher reliability, we feel that we could really provide a better service throughout our manufacturing facility to more quickly respond and adjust. And I'll go a little bit deeper into that providing capable infrastructure. On the screen, you can see right now a drivetrain or transmission where we have many adjustments that we're making and when we're assembling this. And we could take measurements at all these various locations and be constantly sending that information to a central command center, somewhat like what we're talking about that we do in the field for our customers. We could do that in our factory, gather that data in a much more fast and reliable manner in order to emphasize what we always have been doing in our factories, which is focusing on the greatest quality in the industry and on-time delivery for our customers. With all of this additional information, we could even pull information from the field and feed that into this system as well, and it would enable machine learning and artificial intelligence to continue to optimize our operations over time. So as you've heard, we are advocating for rural connectivity and 5G because it benefits our customers. It benefits them in profitability, efficiency, and sustainability in the earth today. So traditional agriculture has been built on bigger, faster, and stronger. And we're very lucky today to be building on that tradition to bring about more automated, more precise, and easier to use, because this builds a sustainable future for the next generation. Thank you.
Thank you very much, Nancy. I find this presentation fascinating because from my perspective as an analyst, it brings together the connected services, connected products, connected operations, all the different manifestations of the industrial IoT. And also it strikes me that the industrial Internet of Things is, let's say it's over 10 years old now, and that agriculture was really one of the initial applications for all these remote access type of platforms, bringing in the different types of sensors and stuff. So I really appreciate that, and I look forward to the Q&A. I have a number of questions myself for you, but we'll move on. And so again, I just want to remind the audience, if you have any questions, please feel free to add them to the Q&A portion of your screen that you can find at the bottom. Our next speakers are from Exor International. We're fortunate to have Claudio Ambra, who is the CTO, and Mark Olding, who is the CMO. So if you guys could unmute yourselves and share your screen, and we'll go from there. And these guys also have the perspective of both connected products and connected operations.
Can you see my screen?
Yes, sir.
Yes.
Okay, well, good morning, good afternoon, good evening, depending on where you are in the world joining us today. My name is Mark Olding. As Chantal said, I'm the Chief Marketing Officer of Exor International. With me, I have my colleague, Claudia Ambra, who's the Chief Technical Officer. We decided to both join on this presentation and panel today so that we can hopefully try and cover both the business and the technical side of what we're doing and our experience in digitalization of 5G. What I'll like to do is go through most of the front part of this. When we get to the user cases, then ask Claudia to come in and give a little bit more detail where necessary. So a couple of questions which I think are important to emphasize. The first one is why you should be listening to this. The thing that's different about Exor International is that we are not a multi-billion-dollar global corporation. We are actually a small and medium-sized enterprise. And this is important because all of the benefits of Industry 4.0, we believe if companies of our size are starting to digitalize their factory positions, then we're starting to get towards a tipping point. As Chantal says, Industry 4.0 is over a decade old now, but still not a lot of people have actually implemented it. If companies of our size start to do it, I think that's going to cause something very important in the marketplace. Exor International is actually now with our factory up to 70% digitalized. We started this some years ago. Here's a rendering of our factory, where you can see on the left-hand side the administrative offices, and on the right, the production plant, which isn't roofless. It's just in this rendering, it has to be. And you can see the data connection between both the IT and the OT worlds, and the use of a cloud and all the data processes that goes on there. Where Exor International is relatively unique is that we are both a user of industrial IoT technology, and we're also a supplier of it. We design and make both hardware, software, and cloud for the industrial automation world. So we're privileged in the sense in that entering into a process of digitalization, we sort of knew the technology we were getting involved with, and we were able to implement it. The vision, the reason why we did this, and the reason why we started doing this some years ago, was that we wanted to acquire data, to analyze data, and to learn from it. Same sort of things that we've already heard from the two other panelists today. The difference with that, of course, is that is part technical, but also it is part mindset, which is a very, very important part as well to get us to think and to work in very, very different ways than we've been doing over our 50-year history. Let me rush on quickly to the benefits that we have seen. The first and foremost benefit for us with this 70% digitalized of our production facilities is that the visibility. This is a picture of what we call the Corvina room, which some people call a war room, which we think is incorrectly named, given that you should have a lot of peace if you have all this information in one place. We call it the Corvina room. And as you can see, it's positioned in our production facilities. And here, all of the information from all parts of our company come into exactly one place, from the MAS all the way to the sensor data information at the production floor level. Here, in one area, any of the people on the C level can come in and they can have a meeting and they can draw up information from any part of the company with very flexible dashboards. And it basically helps us to learn, to see what's going on, to see connections that are happening. And it's quite amazing that I've witnessed when you put people who've got multi-decade information about their actual industry into one room where you have all this data, then they are able to pick up very quickly on interesting patterns and benefits and things that require more detailed investigation. So the benefit to us for having this visibility of data has already been quite immense, quite shocking in some cases as well, but still very, very immense. We've been able to start to implement just in sequence with our suppliers and also internally within the factory. And we've begun the process of zero defects as well. So what seems to have happened is all of this digitalization has really helped us both in hopefully improving our decision-making process, but also in improving our continuous improvements with our lean production ideas. Getting on to the difference with 5G, because all of this digitalization has been happening without the 5G technology being the principal pushing idea behind it. 5G, we think, brings to life our vision of industrial control, because as I mentioned to you before, we are a company that both uses and actually supplies this type of technology. And when we get onto one of the user cases, we will the last user case of the three, where Claudia will go into more detail, you can get an idea of how we think this particular type of technology can be used. The first user case is where we've been using AGV, one of the typical things for 5G, of course. AGVs, although the guidance system is used on either autonomous or laser or metal strips in factories, sometimes these AGVs go off target and they have to be recovered. Not often, but it does happen. Usually that communication is taking place by Wi-Fi. This is also the similar case if you have large machines in the CNC market, welding and so on and so forth. It's not necessarily an environment where Wi-Fi can necessarily be optimal. What I mean by that is that the factory floor is usually a very harsh place. There are usually quite a lot of obstacles. In the process of the idea of a CNC producer, you've got shards of steel and metal that are running off the machine. Not very good for Wi-Fi either. So what we did here is we used 5G and to see how that would improve. And so far, as the results I've demonstrated or showed here, is that we have yet to find a factory setup where 5G no longer succeeds. So far, in terms of the improvement of the communication in extreme factory setups, 5G definitely has led to a positive impact.
So spark few notes
Please.
About that. So Wi-Fi problem, as Mark explained, is we are talking about safety device. So reliability in this case is very important because if you see also in the picture is an emergency push button. And the latency, reaction time is very important for safety. In a standard Wi-Fi, we are able to get something typical to go in the range of 100 milliseconds. In the 5G, we got 1 millisecond on the performance. So we are 100 times faster, and we have the reliability in the message is higher. So this gives a big improvement in the factory for safety function.
Thank you, Claudio. Let me go on to the second user case. Okay, the second user case, and again, remember these are experiments that we've used in our digitalized factory. This is a wonderful position where you have a machine producing X. Let's call it just producing boxes, and it calls in a mobile robot in this particular case that will pick up these finished boxes and place them in a different area. Well, the user case, of course, is where machine A has a problem. It's not going to be able to produce these boxes for whatever reason. And while it has not been able to produce them, it needs to communicate to the mobile robot that that is the case, it has a problem, but also, more importantly, that the robot can go off and do other work while machine A is being repaired or sorting itself out. This is what we talk about peer-to-peer, machine-to-machine communication. One of the most important parts and benefits that can come from using 5G. What we have found with this is that it's working quite well. We have found that the latency on 5G is not yet 100% deterministic. In the case of this particular example, that's not going to be particularly relevant, of course. But in other factory environments, that could be a very important part. It's not yet there at 100%, but it's at a pretty good level to make this work. So we are seeing some very good, interesting user cases for peer-to-peer machine communication. I don't know if, Claudio, you want to add something to this?
Yeah, that's exactly. We are already, of course, connected as a first step, OPC way field bus level communication, and the amount of data, especially in the semantic description of the protocol OPC way, is very high. So the need of 5G is assuring the connection between machine to machine in the real time with a big amount of data. This is very, very good improvement on that.
Thank you. And we'll go to the next user case is the real big one for us, because this is in part of our vision as to where 5G is really going to take industrial communication with the use of AI and machine learning and so on and so forth. So as most of the other speakers have mentioned, there are still some issues with that in the factory floor, and particularly when we come down to the edge. This is where the issues begin. The computing power, the capability at the edge is a very important thing. And we have a vision, of course, of 5G being able to implement industrial control. So this is a very, very important user case for us, and we believe a very important user case for the rest of the implementation going forward of Industry 4.0. So what I'm going to do is I'm going to pass over to Claudio, because this might get a little bit outside of my my pay grade.
Yeah, this is quite an innovative part, and of course, actually, we are also designing our own product. We are develop our own edge computing technology on the field level, where we are integrating in the edge computing the typical services. They are in the control, like a PLC. We are making virtualization of the visualization, and of course the analytic part. In this third case that is we are presenting, we are connecting more edge computing together, and we are realizing edge cluster. This technology, of course, is completely different than machine to machine, because the amount of data they need to have a cluster running is quite high. In this case, it's important to have a redundancy of the data in a different edge computing, and also to support the CPU workload when there is a peak of load, like a camera processing, machine learning, and analytic. So we found the 5G a perfect architecture to have a mesh, big amount of data, and to assure the edge computing work in the cluster computing. So that's very promising. We are in the early stage of these use cases, and we are, of course, using this approach to integrate in the edge computing 5G also devices from partner like AGV, robot devices, automation devices, in order to test different use cases in this architecture.
Thank you, Claudio. I mean, that might sound like us product placement, but you have to remember that we don't make agricultural machines or chemicals. We make industrial edge computing and technology. So this is why we brought up this particular thing. It's a very important part, I think, going forward for the industry, and which is why we wanted to take it. We hope at the end of this particular call, you can ask us lots of questions. We're both going to be available to do it. Thank you very much.
Thank you very much, Mark and Claudio. I really appreciate the way that you guys brought in the innovative aspects of the 5G and the edge compute and AI and ML and other capabilities that you cited there. So I really appreciate that perspective. So our last formal piece will be from Sander Rotmensen from Siemens. Sander is the Director of Industrial Wireless Communication Products at Siemens Digital, and I asked Sander to bring essentially that technical update. We've all spoken to the different release tiers associated with 5G, and Sander has put together some comments that will hopefully ground our discussion as far as where the technology is and where it's going. So Dave, you want to cue that up? Thank you.
I'm Director of Industrial Wireless Communication at Siemens Digital Industries, and I'm here today to talk a little bit about industrial 5G and how it will enable the acceleration of the digital transformation. 5G is the #1 trend in industrial automation. It's the technology bringing everything together, from AI inside artificial intelligence to edge devices to augmented workers. Everything needs communication, and that's where 5G plays a big role. With industrial 5G, we will change the way we make decisions, manufacture projects, and maintain factories. Some of the applications benefiting most of 5G are autonomous machines, such as AGVs or mobile robots. And they all benefit from URLLC, ultra reliable low latency communication, a big part of the 5G standard. But what actually is 5G? 5G is the 5th generation cellular network standard ever brought to market. We started with 1G with voice communication. With 2G, we were able to do digital communications by means of SMS messages. With 3G, we were able to access the internet. With 4G, we were able to fully stream full HD video and music. But with 5G, there was a real focus on industrial automation. So that's the reason why we only started talking about cellular communications in an industrial environment with 5G. So with 2G, we already used it for industrial communications by sending text messages from a machine to a person to inform when something was going on, which was important enough to inform the operators with. With 3G, we were able to live access the PLC from somewhere. With 4G, we were able to not only live access the PLC or a part of a plant, no, we were really able to look at what was going on by accessing a live video stream. But with 5G, we focused on solutions like automation on the shop floor, communication with AGVs, low latency communications, and that was done by companies like us, Siemens, joining the 3GPP early on, making sure the requirements from not only us, but also you, our customers, were part of the 3GPP standardization in the requirement phase, making sure we could find technical solutions for the challenges we have in an industrial environment. So, but what actually is then this 5G and what does it do? So 5G has 3 cornerstones: the enhanced mobile broadband, focusing on high bandwidths of up to 20 gigabit per second. And we have massive machine type communications. Massive machine type communications focus on the connectivity of many devices in a certain area. For example, one of the key points is 1 million devices per square kilometer. And now you might be thinking, 1 million devices, when will I ever connect 1 million devices in a square kilometer in an industrial environment? It's not about the 1 million devices per square kilometer. It also means one device per square meter if you calculate it down. And all of a sudden we're talking about process automation with many sensors. And now we could think about massive machine type communication because it also supports low battery usage. So combine those two things together, you actually have an industrial application you can support with 5G. The most exciting thing about 5G is ultra reliable low latency communication. With ultra reliable low latency communication, we can achieve highly reliable networks with a reliability of 99.999%, as well as sub 10 millisecond communication. Sounds too good to be true, right? Maybe it actually is too good to be true because it doesn't do this all at the same time. If we focus on if we want to focus on low latency communication, we for sure cannot achieve the highest bandwidth. And that is something we need to think of when we already set up the network. So already from the get-go, implementing 5G in a factory environment, we need to think about what we want to achieve in the end game. Some of the applications we've plotted in here in the same triangle, where you see things like remote control, which is actually what we already do today with 4G. It's also possible with 5G for sure. And this is something which is a little bit in the middle. You need some bandwidth, you probably have a lot of devices connected, but you also need some latency because you need to be able to work with it. Or the massive wireless sensor networks I mentioned in the previous slides. Another key application is augmented reality, adding an additional layer to your manufacturing floor, making human machine interfacing of a whole new level. But the exciting things are automatic guided vehicles, mobile robots, meaning robots becoming cobots because they can start to cooperate with each other, and of course wireless safety, which we already have been doing with industrial wireless LAN over the past years. Making the applications happen we just seen, we need industrial private networks. Private networks are the key to success because you're able to operate the network yourself. You can make sure it's flexible enough to support all the different requirements your applications have, as well as it enhances your data privacy because you can keep confidential data on site prior to sharing this outside of your premises. But to set up a network such a way, you need to have access to private spectrum. As Siemens, we've played a big role in, for example, the spectrum availability here in Germany, where we have 3.7 to 3.8 gigahertz available for all industrial campus networks around the country. And also other countries have been adopting this. For example, in the UK with 3.8 to 4.2 gigahertz with shared spectrum, and we already had CBRS in the United States, as well as many other governments where we are still in contact with to advise them on making spectrum available for innovative 5G industrial communication networks. So where do we actually stand with 5G? So with 5G, we started with release 15. And you might say, now, we started with release 15. Sounds like we're already way on our way. That's not really true because the 3GPP, the 3G partnership project, started with development of 3G, which is release 1 to 7. Then release 8 to 14 was 4G, and release 15 is the first 5G release. It first focused on the use cases of the mobile network operators, making sure that we can have access with our smartphones, have high bandwidths available so we can serve quicker, we can stream better quality. But first with release 16, it's going to be exciting for industrial users because that's where we enable low latency and high reliability solutions in the first step. And I will extend with release 17 and even with release 18, you will see new use cases for industrial environments. All of these things are really bringing new possibilities to industry, making sure we can find innovative new ways to work with this exciting technology. So based on this, it seems like release 16 is already available, so we can start today. But it's not the standard what counts. Just a bunch of papers won't help me bringing 5G to real life. First, we need to get chipsets. Based on chipsets, we can then start developing products like we did with Scalens MUM 856-1 coming later in this slide deck. And then you see, having a standard available in December 2018 brings us to products in spring 2021. Meaning that now release 16 is available on paper, we can just start to play with release 15. And this is something we really need to take into account. Meaning a standard is ready doesn't mean I can really start with it in a productive environment right away. And you see the same for release 17 and possibly release 18, where dates have not yet been announced. This is all part of a study from ARC, which is shared in this event. So make sure you read it. Very valuable information inside. And what is Siemens actually doing actively now? So what we have been doing so far is we have developed our private standalone 5G test network. It's an in-house development, fully controlled by Siemens, and we have already rolled this out in our Siemens Automotive Showroom and Test Center. This is a location in Nuremberg where you can really see 5G in an industrial environment at work. It's safe. So we work on a full 5G ecosystem from core to a central unit, through distributed unit, to radio unit, and of course the end devices, which are key to being ready for industry. So we test this in a realistic environment already today, because before we bring such a solution to market, we want to be completely sure that this is stable enough and really a benefit to the shop floor. We're not only testing, we have been developing an industrial 5G router for public and private networks as well. The device is compatible with 3G and 4G, so you can start today and be ready for 5G tomorrow when it rolls out in your area. The device is in an IP65 housing and is therefore ideal to be added to brownfield solutions. For example, when you have a sunsetting 2G or 3G network, you can start using this device right away. Combined with Cinema Remote Connect, our VPN management platform, this is the ideal device for secure remote connectivity to plants located remotely or in other countries. Now we have reached the end of my presentation. If you have questions, please ask them during the panel discussion or contact me after the session directly. Thanks for your interest. Have a nice day.
Thank you, Sander. And I want to send you a second thanks, because I gave Sander only 10 minutes because we did want to include the technical piece that he provided. And I kept coming back and saying, can you add this part? Can you add this part? So I really appreciate him putting that together for the audience education. So I'd like to ask all of our speakers to please go onto your webcam and unmute yourself. I also want to introduce Ricky Watts, who is the Senior Director for Intel's Internet of Things Group, who's also joining us for this panel discussion. So we have the view, Okay, great. So one of the things that I'd like to address, and also my colleague from Munich, as I mentioned, David Humphrey, is here to help me with the questions. So I just want to make sure we have Pietro, Nancy, Exor, Sander, great. Okay. I wanted to start with a general question and get everybody's perspective on this. Sort of the elephant in the room in terms of the 5G ecosystem question is the telecom providers. And we've written at ARC about, say, like when Ericsson bought Cradlepoint, who was a cellular router provider. You know, in our mind, that addressed a gap that we perceive between the telecom operators, network management expertise or core value proposition, and the operations expertise that's required to actually solve manufacturing problems. So I'm just curious, do the telecom operators and what they do play into any of your solutions, or are they totally out of it? And what are the implications of that? Can I start with Pietro? Can I start with you?
This is a loaded question. Well, I mean, in our experience, we had some tests in different parts of Europe, and in collaboration with different telecom partners. Clearly, they bring a lot of knowledge on setting up private networks and so on. What they are missing, however, is the view on the customer, because their typical customer, we are completely different from their typical customer. Typical customer has a profile, user profile that is connected to a tablet, a cell phone with a very specific application. It can be Facebook, can be YouTube, can be Netflix. I'm not doing any advertisement here. It's I mean, this is the user profile that they are used to. Although they have the knowledge and everything, they have much less understanding or experience with industrial customers like us, because we are posing question in terms of upload, download, or dynamic upload, download, or coverage, dynamic coverage, and so on. So things that challenges that they have not used to face. So I would say there will have to be a lot of knowledge transfer on our specification, industrial specification.
Nancy, does the telecom operator play any role? I know you have your private installation, but how about in your connected products, for example?
I mean, currently today, of course, the reliability of those networks plays a big role, right? And where we have service plays a big role to what we can provide for our customers. I don't have as much knowledge about how that goes forward with 5G, but for today, of course, it's critically important.
And do you find that they have the operational expertise, or how do they bridge that gap? Do you fill in the holes, or how does that work?
No, we are not. Well, we're working with different providers in order to try and fill in the holes. So we don't have like a one-stop that can do everything worldwide for us.
Right.
And so we're working with the experts, especially in different regions. But of course, we're staying in touch with many of the providers so that we can see what the best advantage would be also.
Yeah, we find that too. That's why I cited it as an ecosystem approach. So Mark or Claudio, do you have any comments as to the role of the telecom providers in your installations?
Yeah, I can share our experience. We are located in Italy. In Italy, we have the license of frequency. The carrier is provided like Telecom Italy. So it's very strategic in the ecosystem, of course, the relation with them. And so because the frequency we are using now in building, but still the frequency is in the license of telecom provider. The good point we found after the first installation is that it's very synergic for us for the development product. As you mentioned, Mark, before, we are also making edge computing, and this is enlarging the infrastructure using the telecom provider, like end user, other factory, they want to do the same experience, and this for us is a good ecosystem that we are working.
I'd also like to add, Chantal, I don't actually think that it's the job of the telecom providers to get down to the operational level. I mean, their role and where their money is obviously in just rolling out this as much as they can to everyone they can. The quicker they manage to do that and get the prices down, the quicker that everyone is going to get the benefits of it, right? And that's the whole point about Industry 4.0 is not that the massive, with all due respect to the three companies here, is not that the massive companies get the benefit. It's supposed to be disruptive, right? It's supposed to be that the small guy comes in with a disruptive technology and just changes the market. Unless we get this Industry 4.0 down to the small and medium-sized enterprise level, we're going to lose a lot of that type of innovation. So the role of the telecoms is very important, but to me, it's to roll it out, not how you implement it down at the floor level.
Okay. And Sandra, do you have any perspective on that?
So I agree, actually. So we need to try to make sure we create a 5G solution suitable for small and large companies. And I think the only way to do is that to create a private infrastructure based on private spectrum or sub-licensing of spectrum. So therefore, I really think with 5G, we will go in an area where we see private networks taking the overhand in industrial environments. However, I still see a role for network providers as well. They have system groups, they have the knowledge, they could maybe jump into private networking themselves. We see some mobile network operators coming from overseas in regions where they don't have spectrum, trying to get active in that area to provide those as well. But I fully agree. With 5G, we can be disruptive, and I think what we as Siemens are doing is bringing something to the market we've never seen before. We will make sure you get your hands on 5G for everyone.
Okay. So I guess, Pietro, go ahead.
I respectfully disagree on one point. Yes, it is important, absolutely important to bring 5G rollout and make it the most possible available for really bringing on board all the benefits it brings. My point on is that the 5G brings additional features that are not present in any other type of application. We're talking about slicing and so on. those features are the one that will really make the difference for the manufacturing industry. Those features are also the ones that no one knows about. So that's why I'm saying the experience the experience must grow from the operator on this specific feature for the industry. That experience is not there yet.
You know, Pietro, I actually had a flag that I wanted to follow up with you because I believe Sander had it in one of his graphics about, but I never addressed the whole topic of network slicing, which is a significant value proposition within the 5G technology. Can you speak a little bit to what network slicing would do to you in terms of for you in terms of the value proposition? Yeah.
Without entering, I mean, it's a very technical discussion here, but for manufacturing production, and I suspect it's the same for other manufacturing industries, there are different levels of network that we are using, from office down to secure, secure, critical, and so on. The idea of using slicing is that instead of setting up, as we do today, 3 or 4 separated wired networks in the same place, we can just set one 5G and automatically through the slicing. Slicing means having one frequency, one infrastructure, and running a certain number of independent networks on them. So basically you are building what is the physical different networks into one network. So it's a huge saving. That obviously implies a lot of, building the experience.
What kind of timeline do you think that would take? Or, how far out is that vision?
That's another question again. It depends. I mean, if it was for me tomorrow, because that's a clear saving that we can have and clear enhancement. And it depends on the release, 3GPP, when they slicing is not, as far as I know, and Sander, correct me here, you are the expert here, is not, slicing is not in the current release. Before we can actually achieve that, we need hardware that implements the release 16, 17, I don't remember this one, but we are looking at least 3-5 years. Mm-hmm. And once the hardware is available, then we have to build the experience before I put all my critical equipment on that.
Right, yeah. That is part of the challenge here because, a lot of what we're talking about, certainly we have, like John Deere's buying Spectrum and implementing private wireless, and we see the trials that are presented in the report, but it's still sort of futuristic. And certainly people like Nancy mentioned have the experience, say, with the 4G LTE, et cetera, but there's a lot of unknowns. I mean, there's a lot of hype and a lot of promise associated with the capabilities of the technology, but like Pietro said, in many cases, we'll just have to see. So I'm also curious, one of the things that I mentioned as an inhibitor, and I think almost everybody else has mentioned, is the whole concept of the infrastructure build out associated whether with 5G or with private wireless. So I'd like to ask really everyone in the panel to speak to, just how large of a task is that going to be, and how long do you anticipate it will take to achieve payback or return on investment? So Nancy, do you want to start with that? Do you have any thoughts on that comment? Sure.
I think if you look internal to our factories, it's much more of a contained environment. So we can have a better vision on what it would take to do the build out, how long we think it would take to have a payback. I don't know I'm not working directly with the manufacturing folks day in, day out. I don't know exactly what the estimates are. They're still preparing what it would take. But like I said in my presentation, we do think when we have that infrastructure and we've got all these capabilities, if 5G delivers on, that capability, then we would be able to do fewer installations. So we actually feel like we could invest more, up front because it'll last for 10 years rather than only around 5 years. And just even the flexibility as we change products, we would be able to shift with it. So we could invest a little bit more and still see an ROI. That's our opinion there in our factories.
I flagged your comment about the 10 versus 5-year life cycle of the equipment. So even with all the different releases of 5G and their varying functionality, you do see it as really doubling the infrastructure lifetime?
Because if you think about the physicality of a factory and how you run things down a line and how today the network drops and all of that infrastructure has to be replaced when things are updated, we wouldn't have to have that. There's less of a physical connection to changing our line slightly, et cetera, and having to reroute all of that, the labor to do that. So updating some things is less, we feel anyway, that would be, it's going to be easier and less costly during that 10 years than having all of those physical connections that have to be routed in a very complex and large factory environment.
Great, thanks. Do any of the other participants want to speak to the issue of infrastructure build out and what manufacturers can expect?
Yeah, I think I'd like to say something. So when we talk about this, and I really like the way you're thinking, Nancy, by extending it from 5 to 10 years, I will definitely go beyond it because we've been doing 10 years for years now. But that's one thing is for sure. We are not in here for the short term. So we won't be seeing customers rolling out release 15, then rolling out release 16. So what we need to do now as a manufacturer, you need to wait for the right moment to step in, which we believe that Siemens is release 16. Don't go before that, from my point of view, because release 16 will really bring some key features in there. And then especially with the flexibility of wireless connectivity, it's easier to expand. And I think one of the things which you have with 5G, when you're in the ecosystem, you will have backwards compatibility, so you can just add newer parts to the system to upgrade it. So I think that is definitely something which is very interesting and something to take a look at. Yes.
To that point, I made a comment about DSS or dynamic spectrum sharing, which we've sort of seized on at ARC because of the nature, really the longevity of manufacturing installations relative to, say, other cellular applications. So have folks considered, whether or not, or is dynamic spectrum sharing sort of part of the value proposition in terms of that type of future proofing? Is that concept important to anyone here? No?
So I can say also why. The fact is, if you want to do dynamic spectrum sharing, you need to have access to spectrum, and the XM doesn't get more. It's just the spectrum you will have. So if you want to share the minimum amount of spectrum you have, you want to share that amongst two technologies. You have two technologies working at half the performance. So that therefore I would say this is something we shouldn't be looking at, and also you need to sometimes, depending on what you're sharing with, but with the 4G and 5G spectrum sharing system, you will need to take care of parts of your network redundantly. So maybe two kind of radios in the field. So that's an additional cost you will have, and they don't really see the benefit in it.
Well, some of what the feedback we've been getting, Sander, has been, with the future nature of the 5G value proposition, some customers are looking at DSS as a means of starting with, say, 4G LTE and then migrating into 5G. So that's come up on that front. Okay.
Yeah, I understand where it comes from. A fully valid point.
Great. So there's only a couple minutes left here, but David Humphrey, I just wanted to bring you in. Do you want to, raise any questions with any of the panelists?
Sure, I've got a couple of questions. We're talking a lot about cybersecurity in industrial automation architectures, and one of the great features from the very beginning about 5G was it was said to have built-in cybersecurity rather than the bolt-on cybersecurity solutions that we're used to. But at the same time, the priorities of cybersecurity for commercial companies, the banks and the insurance companies, tend to be different from the priorities in cybersecurity for industrial companies. And for those of you who are intimate with the specification, I'm thinking maybe Sander, does the built-in cybersecurity in 5G address the particular issues that we have in manufacturing and industry? And does it address the special priorities that we have? As an example, priority in industry is equipment availability versus, say, data integrity.
Yeah, that's a valid point. That's actually that used to be one of the slides I showed sometimes. So I think 5G does a very good job. So I think all the built-in security mechanisms make it better as any of the technologies we have seen from a cellular perspective. But I also think we need to go even beyond that, because I think by just looking into the built-in security, which is sometimes nice and interesting, we also need to make sure we have a multi-level approach. And that's what we advise our customers to look into, like a system with multiple layers and so on, ensuring that you have the reliability, that you have the network up and running at all times, but still maintaining it secure at the same time.
Okay, well, I'm getting flagged by my production team that we have to close up. And as I said, this is a fascinating topic, and we could have had a discussion on each one of your presentations. But I do want to greatly thank all of our participants here. I really got a lot out of what you shared with us. And to the audience, I want to remind you that we do have resources available on the VFairs platform that relate to 5G, as well as all the other topics that we've covered in the forum. And again, please take a moment to provide your feedback on the Rate the Session survey. And thanks again, everyone, and have a great day. Take care.
Thank you.
Thanks.
Thank you.
Bye.
Bye.
Bye.